So in this presentation, I will uh, provide a description about the energy efficiency. We will start by a definition of energy efficiency, then definition of the decarbonization, and how we work with the energy efficiency and the different sectors where we can work in energy efficiency. And then we will go through the steps in ESCO projects. To do the energy audit, we have the utility bill assessment, measurements, energy use breakdown, ESM identification, and saving calculation. We will go through these steps in each ESCO project, and at the end, I will go through another presentation regarding the decarbonization. First, as a definition for energy efficiency, energy efficiency means using less energy to perform the same task that we are usually performing, and to produce the same output. So the purpose is to eliminate the energy waste and keeping the same performance and comfort level and productivity. As an example of energy efficiency, we have the famous action done by everybody is replacing the conventional lights by LED lamps. But why we do energy efficiency? For several reasons. The energy efficiency will lead to cost saving. If we reduce the energy consumption, we will lower our energy bills. But also, this will lead to better environment. We will work, and doing energy efficiency will lead to decarbonization, better environment, fighting climate change, and energy security. So it's not only related to cost, it's also related to other impact that will happen after doing energy efficiency projects. Now, what is decarbonization? That is as another step that resulted from the energy efficiency. Decarbonization is the reduction or eliminating all the CO2 emissions. We will move from a carbon-intensive economy to low carbon. We are now in economies that emit too much of carbon. We will see later how much carbon are emitted and what are the impacts of emitting that much of carbon. As examples of decarbonization is to shift from the coal to gas and gas to renewable energy. So the renewable energy will not consume fuel, will not burn fuel, so will not generate CO2. And another example is to improve the efficiency. So we will be generating less amount of CO2 for the same work that we want to do. So these are the main two examples about the decarbonization. Okay, how we work now with the energy efficiency? There are different types of projects where we work in energy, and where we improve the efficiency and we save energy. We can classify it into three categories. We have first what we call energy conservation, then the energy efficiency, and at the end, the renewable energy. And the first step, the energy conservation, We look in this type of project for the simple steps that can be done that is not costing too much, that are related, for example, to turning off lights, turning off the equipment that are operated outside the hours required for operation. Uh, so, for example, sometimes you have the AC that you keep it on for while the room is not operated or not occupied. So this type of energy is lost for nothing, and this action is not costing too much, or it's a simple action. It's related to behavior. So this is called energy conservation. Then after that, we look to more complicated tasks, that, for example, replacing all the lights, which requires a certain amount of investment, where we can also propose VFDs. We can replace chiller to improve the efficiency in the building. So this is another category where the cost is a little higher. Then after these two types of projects, we reach the phase where we can implement renewable energy, because it is not good to implement renewable energy while our consumption is very high and we can avoid some of this consumption. So the best case is to reduce first our consumption, then from this remaining consumption, we will install renewable energy to cover part or all the consumption, the remaining consumption. So as a priority, as we said, we will start with energy conservation measures that are behavioral or operational change. They are low cost, or even no cost sometimes. The payback is immediate. So if, for example, if we start to change our behavior regarding turning off and on ACs and lighting, this does not require any investment, and we will see the energy reduction, energy saving in very fast time. While the energy efficiency measure are related more to the equipment themselves, like the chillers, the split unit, replacing it, controlling it, and most update are related to upgrade in the technology. For example, old split units were the conventional split units were on-off unit, while now we have the inverter unit. So as the technology improved, we can have better efficient equipment. So this type of project, the cost is between a medium to high, and the payback, sometimes we have payback for 3 years, sometimes for 5 years, depending on the type of the activity, but it is in this range, can go a little up. But the last thing is the renewable energy. We will generate clean energy. It is high cost. We need big investment, and the payback is usually higher than the project with the energy efficiency measures. So we can work in different type of sectors. We can work in the residential sector. We can work in the commercial, industrial, and transportation. Each type of sector will require specific ESM. For example, in the residential sector, we can change the lighting. We can change the appliances. We use better appliances. We can do some insulation of the buildings and work on the HVAC systems. In the commercial side, It is more related to energy, to building design and to energy management system. So it is more about control of the existing buildings. For industrial sector, changing LEDs and this type of ESM will not have big impact compared to the overall consumption that is mainly due to the manufacturing process. So more work in the industrial sectors is related to the optimizing the process of each factory, and to try to recover the waste heat that we are having from furnaces or any other type of equipment that is generating heat. This heat is going to the atmosphere without any. We are losing this heat. We can take this heat and using it in another type of activity. We can generate electricity from this heat. We can using it to heat to boil something else. So we, instead of losing this amount of heat, we can use it. So this type of work is more in industrial sector. And in the transportation sector, we can use fuel efficient vehicles of electrical vehicles to reduce the amount of fuel that we are consuming. So each sector will have different type of work in the energy efficiency. So now we will go through ESCO projects. What are the steps in an ESCO project? ESCO project is a project that is done by an ESCO company, energy saving company like our company. We have three major steps. We have the first step, which is the energy audit phase, then the implementation, and then the reporting period. During the energy audit phase, we go to the facility. If we have a hospital, for example, we will go to the hospital and try to understand the consumption inside the hospital and try to propose what kind of measures we can do to reduce the energy consumption. So all of this is done in the energy audit phase, where we propose ESMs and propose the savings that we are going to achieve, and we provide the cost and payback of these ESMs. After the energy audit phase, we will move to the implementation phase. For example, if after the energy audit phase, we propose to replace the chiller, that will cost that much, and will have the payback of 7 years, for example. Then in the implementation phase, if the client agrees, we will go to executing this proposal. So we will replace the chiller. Usually the energy audit phase is taking around 2-3 months, up to 4 months. The implementation phase can take up to 1 year to deliver the products and install them. Then after the implementation phase, when we implement the ESM, we will go to the reporting period. During that reporting period, which will last, for example, for 10 years, 7 years, depending on each client. During this reporting period, we have to prove that the saving is achieved. And depending on the contractual agreement with the client, during this reporting period, we have to guarantee, and if the saving is not achieved, we have to take the responsibility of the penalties that will be issued during this due to this. So, as a summary, the energy audit phase takes then up to 6 months. The implementation near 1 year. The reporting period can go up to 10 years. For the energy audit phase, we have different type of audits or level of audit depending on the details we go through. There are three different levels, ASHRAE level 1, 2, 3. The difference between them, as I said, it's related to the details. For example, the ASHRAE level 1, we call it walkthrough analysis. In this case, we enter the facility, we just it will take 1-2 days, nothing more than this, and we will get information about the main systems that are consuming energy, and we look for the ESMs that can be done, but we will not do a detailed analysis. We will not do measurements. We will not do simulation. We will just estimate that based on what we saw in the walkthrough. We know that we are going to replace the lights. We are going to implement control on the HVAC, and this audit is very short duration, and the results are not accurate all the time. So the client will have a little idea about what type of ESMs we can do, and what is the estimated cost. Usually the cost can go up to plus 20%, plus minus 20% at the end. But it is an important phase to have for the client to have idea about what kind of project we are going to do. For ASHRAE level 2, in this case, we will go more details in the audit. We will gather information about more details about each type of equipment. We can do some measurement in this level. We do a lot of calculation. We do estimates, cost benefit analysis. We go through the lighting, HVAC, building envelope, but in this case we will not do simulation, and we will not go through every details in the facility. At the end of this audit, the client will have a better understanding of the situation. We will be able to propose more detailed ESMs with a better calculation and a better cost estimate and payback. The last type of audit is ASHRAE level 3 audit or investment grade audit. In this case, we will go to every details. We will do measurement for longer period. We can do modeling. It is an in-depth study, and it can take several months. And for example, measurements, we can take measurements for up to 1 month in this phase. And at the end, we will have a very detailed calculation about the saving and the cost and the payback of this project. But that, we can say that the most level 2 is widely used, the ASHRAE level 2. If we need additional details and more in-depth study, we go to ASHRAE level 3. Whenever we have a project where we have to start with energy audit, we have to go through these 12 steps. We have to do first utility bill assessment. We will take information about the bills of this facility, and we will study these bills. I will go through it later on. Then, after doing the utility bill assessment, we will do measurements for key parameters. Based on each type of site on facility, we will select the important parameters that we need to do measurements in order to uh, proceed with the project. After doing the measurement, we reach the phase where have to create the baseline and to do the energy use breakdown. We can say, know that this facility consumes 10 million kilowatt hour per year, distributed over the month in a specific way. And now we need this 10 million, how it is distributed between each type of equipment, lighting, chillers. So this is called energy use breakdown. After the energy use breakdown is done, we will look into the what are the possible energy saving measures that can be done. We will identify the ESMs. After identifying the possible ESMs, we will conclude that what are the direct energy saving, and we have also conclude the indirect energy saving. Based on these ESMs and the saving which we are estimating, we can do the evaluation of the ESM on the technical level and on the financial level to see are these ESM feasible. Sometimes we can propose to replace a chiller, but we found that the payback is more than 15 years, for example, so it will not be a feasible solution. After evaluating the ESMs, we will go to the implementation plan, where we'll do the plan on how are going to implement these ESMs. And an important part, we have a separate session for the MNG, is the measurement and verification. We have to do at the end of the audit measurement and verification plan. As we said, that the last phase in an ESCO project is the reporting period. During the reporting period, we have to verify and report and guarantee the saving. All these will be based on the measurement and verification plan. After we complete all these steps, we will do the audit report and present it to the client. Now I will go one by one in these steps. The first step is the utility bill assessment. We will get from the entity or from the facility the consumption over 1 year. We need a 1 year consumption minimum. It can 2 years or 3 years will be better to more understand the consumption, but at least we should have 12-month consumption. This is important for us. First, we will calculate what is called energy use index intensity. This is how much energy we are using per meter square of this facility. We have a facility of 10,000 square meter, and it is consuming 10 million kilowatt hours. We will compare it to the ASHRAE EUI. This will give an idea on the potential of energy saving in this facility. If the facility energy use index is less than the ASHRAE, this means there's no much potential, but if it's higher, we have a big potential. And this comparison is done based on building type. And you compare a hospital in Bahrain with another hospital in Bahrain. university with university, residential building with residential buildings, and in the same area. And the utility bill is used also to determine if you have any unusual type of unusual consumption. Sometimes you see that the consumption is increased, is doing a spike, sudden increase and decrease. And we will see this and try to understand what are the reasons of this. We will see the variation of the consumption based depending on the season. You have some type of client that is consuming with a tank that is, there is no difference of consumption between summer and winter. Mainly these are production plant where they produce the same amount each day. But we have, for example, the universities, you will see that in the summer, for example, that the consumption is reduced, maybe because the students are not there, while comparing to other months where there are classes. And other type of buildings, they consume based on depending on the weather. You have in the summer you have the need for cooling, while during winter no need for the cooling, so the consumption is reduced. So all these we will study this utility bill based on what are the parameters that are affecting this bill. The second step is doing measurements on key parameters. To do the measurements, we have different type of measurements and measurement tools that we are using. I will give some examples here. We do the measurements for the electrical parameters like current, voltage, frequency, power, active and reactive power. Using the energy analyzer, we install this equipment on the main energy consuming equipment like chillers, AHUs, pumps. We put it for a period of 1 week, 2 weeks, 1 month, depending on the type and the type of the equipment and the case by case basis. We have other than the energy analyzer, we have the BTU meter. The BTU meter will measure the flow and supply and return temperature to to calculate the thermal energy. This is important because we don't look only on to the electrical consumption. We care about the electrical consumption also when if we link it to the thermal energy consumed. Yeah. For the chiller is providing at the end cooling, so we need to understand how much cooling is provided to this building. So that's why we installed BTU meter and making logs for the thermal energy. In addition, we can use thermal cameras to identify spots on pumps, for example, on the windows where we have heat dissipation. This will appear on the thermal image. We have the lux meter, and we are using this device to measure the intent at the lux level inside the working space or the space we are addressing. This level is important because whenever we are going to replace lighting fixture, we have to ensure that the new lamp that we are going to install will achieve at least the same lux level. don't want to affect uh, the comfort of the occupant. So this is important to measure. We have other type of measuring device like the occupancy logger. This device is used to log the occupancy inside a room. We can install it in the room. It will log that. It will detect the presence of people inside the room, and it will log it. So we can understand from this how much this room is occupied, and we can compare it to how much this room is illuminated, as we will see later in the measurement. Also, another type of device we can use is this device is called on-off motor logger, where we put this device on the motor case. This is based on the electromagnetic effect. It will know that this or record if this motor is operating or this motor is off. So we will have a log for the status of the motor on off. Also, an important device that is used is the indoor air quality logger. This device will measure the temperature, humidity, and CO2 level in the space. This is also related to the quality of air inside the room, which is directly related to the occupant comfort. We have to see how much the temperature is, the level of the temperature and the CO2 level and the humidity to try to detect if we can, from this information, we can know that if we can work on ESMs or we have to keep this level in our ESM that we are proposing. We cannot alter this situation. And last, we have the multimeter, which is used to do spot measurements for the voltage and current and all electrical parameters. All the above are loggers. We can keep it for a specific time, while this multimeter, it is just spot measure. How we can work on the saving for the motors. The energy for the motor is the kilowatt of the motor time multiplied by annual operating hours. So here we can work also on these two parameters. If we want to work on the kilowatt, this means we have to upgrade the motor with higher efficiency motor. Better efficiency means for the same amount of work we need less kilowatt. So we are reducing the kilowatt. We reduce the energy consumption, or we can reduce the kilowatt by the addition of VFD. By adding VFD on the motor, this will reduce the energy or reduce the kilowatt, and depending on the reduction of the frequency of the motor. You will see later how. And also we can work on the annual operating hours. If this motor is operated during time where we don't need the operation of this motor, so it's better to turn off this motor. In this case, we are reducing the annual operating hours, and accordingly we are reducing the energy consumption. How we can calculate the energy savings by adding after we add variable speed drive. This will depend on is based on the affinity law. The affinity law will give us, it will link the flow with the speed, the pressure with the speed, the power with the speed. So if we reduce the speed by 50%, the flow will be reduced in the same way, because flow is proportional to the speed. But the pressure overhead is proportional to the square of the speed to the power 2. And the power is proportional to the speed to the power 3. And this is the main point here. If you reduce the speed by 50%, the power will be reduced 87.5%. I'm talking theoretically. Yeah. So a small reduction in the speed will have a bigger impact on the power. Bigger impact on the power means bigger energy saving. Now we'll talk about the cooling, the saving, how we can work on the cooling side. Here, to calculate the cooling saving, we should look to the thermal power. The thermal power is linked to the GPM, the flow. Here we are talking about chilled water network, so the GPM flow of water times the delta T, the difference of temperature between the supply and return of the chiller, of the supply and return on the sides of the pumps. So if we want to reduce the energy saving here, we can work on the GPM and the flow. By reducing the flow, we can reduce the thermal power. By reducing the thermal power, we can reduce the electrical power, because the electrical power is linked with the thermal power by the coefficient of performance. So if we are talking here about chiller, the chiller is characterized by its COP. So we have chillers of COP3. This means that for each kilowatt electrical we have thermal power 3 kilowatt of thermal. So reducing the thermal power, we will reduce the electrical power and we will have energy saving. In the same way, we can do on AHU. Here, the thermal power on AHU is directly related to the CFM and delta T. 1.08 times CFM, which is the airflow, and delta T. So also we can work on the CFM. We can reduce the CFM by reducing the speed of the motor.